Hey, how's it going, everyone? Getting things set up here. We've got a plan for today. We've got actually a lot of stuff happening today. We've got, what is it called? A podcast that we're going to do. Oh, wait, not there. Where's that? Did I put it? Oh, right here we go. We're going to do a podcast later today. And we'll be talking about this a little bit. Mostly talking about, what else is going to be? It's artificial intelligence is what it's going to be about. Also, today we're doing Pytorch. Let's see here. Let me get things set up here. All right, let's do tmux again. Let's do a clone on this repository. I'm kind of excited about this. This is the one that I've been wanting to do for a long time because this is an important aspect to understanding how AI works and things like that. Hey, Quantum, good to see you. Welcome on in. Happy Friday. We're got the end of the week and already the end of the week. I'm really excited about this because it is the right. We can relax for a little bit over the weekend. It's good to see you. Let's see. So we're going to do Neva's Pytorch guide for the matrix manipulation functions. This is important because when you're manipulating matrices within Pytorch framework, if you do that outside of the tensor, you break the graph, which causes slowdown in your model. I want to make sure, obviously, when I want to manipulate matrices, I do it myself. All the way along. However, what I want to do is use all of the built-in methods for Pytorch, which gives you the ability to keep an unbroken graph, a clean graph. That way it can do all this sort of acceleration and you get the maximum benefit from Pytorch. There's a lot in here. Scrolling through it, I didn't realize how much it was. I was just like, oh, this will be easy. No problem. Let's look through a few items here. There's quite a bit there. So let's see. Let's get through some of it here. Let's clone this repository and then have it locally. Let's grab this here. All right. So git clone repo cd pytorch. All right. Let's see. Can we run it? Python main. Let's see if we even have everything good to go. I don't even know if we have everything good to go or not. How's it going there, Mubarak? Can you put on the song Gazolo? I don't think so. Hey, Eduardo, how's it going? Welcome on in. Hey, guys, good to see ya. All right, so it works. This is great. Okay, fantastic. Now we're going to be able to do, as you can see on the screen, there's no errors, so that counts, right? That counts. I'd love to put on more music. The challenge is copyright, right? Copyright things. We got to be careful about that. Tell an agentic AI to generate a cheat sheet and reference it as well. That's a good idea. Yeah, that's another good one. I'm pretty sure maybe that also might be what Neva did. I don't know if that's what happened or not. I'm assuming so. All right, fine, main. All right. So this is the entire file. And there's a whole bunch of it's commented out functions here, right? So if we uncommented all of them and just saved it, let me close this and we rerun it. I wonder what would happen. We'd see a giant screen full of a bunch of stuff, would we? Yep, there we go. All right, look at that. Whoa, there's quite a bit. There's quite a bit there. Cape Town, how's it going over there? In Cape Town, we're over here in Seattle, Washington. Hey, Steven, how's it going there, Renee? Good to see you. Me and my friends are trying to build something. What language? Could it be a game? Oh, a game? We want to build a game. So there's a lot of different. So if you're doing it I would say maybe if you can Python because it's easier. If you're looking for more high performance, now you want to get into languages like C or Rust. That's what we're doing. Greek, lol, yes. Yo, hello, happy coding. Yeah, absolutely. So if you're trying to build a game, that's the way to do it. New to Python programming. Hey, Shot, how's it going? Shot Whispers. Can you tell me what to do? I have no idea about programming. I'm interested. Python is a really great start. We're working on Python right now, though today we're going to be doing Pytorch. So it's not quite game development, although that's the whole reason why I got into software engineering is I wanted to be a game developer. Hey, Savan, good to see you. Anthony, hello. Savan, it's really good to see you. Hope you're having a good day. Are they talking about a betting software? Betting? So gambling, right? We got some laws and regulations on that, don't we? If that's the case, well, gaming and betting, that's a really good point. Gaming could also be a synonym for betting. That's something I keep forgetting about that. Yeah, I'm gonna follow you now. Sounds good, Whisper. Thank you. Good to have you. Hey, Goku, good to see you as well. Goku, saw some messages from you earlier yesterday. Roman Rogers, I'm in the right spot, but where are the cryptographers? Hey, they're all around. They're all around us. You never know. They never know the cryptographers. Cool Friday night. Thanks. Want to build an app like Avon? Is it possible? Yeah, isn't it? Why not? Of course, do it. What is Avon? Avon app? I don't know what this is. Is this Avon Go? Is that what you're talking about? Shop Avon as you land. Is this the one you hear? Avon? There's a lot of Avons. You got to be more specific. You got to be more specific. You see, do you remember reviewing my portfolio? That's what it was. I saw your portfolio. All right, so let's take a look on stream. So let me hide this really quick. 1 second. Let's do that. That's one thing that we said we were going to do. Yep. Goku. So let me go to my direct messages. I'll find you. All right, so let me click this. Here we go. You guys, check it out. This is Goku's portfolio. I like the little mouse cursor following thing. That's pretty neat. That is pretty neat. I like the pretty sort of like the gradient text that you got here. The gradient text looking nice. Looking nice. My dog Steven. Hey, we're back. Hey, the famous, the infamous. There we go. The infamous. Good to see you. What are we seeing on the screen? Great to see you, Steven. Always a pleasure hanging in there. Savon, sounds great. Sounds great. So you're just positive and alive. Yeah, that's what. Shot Whisper, you got it. I hope this channel grows. Thank you. That's great feedback. I appreciate it. I'm so excited right now. We've got a really fun day today. I love the purplish colors. Yeah, exactly. It's pretty good. 8,000 downloads. I don't know what these numbers are about. Is it really 8,000? I think that's a static number. Although it's pretty neat that you have it on there. You had email, phone number, LinkedIn. Does that work if I click it? You should make this clickable. So obviously I can copy and paste it. I can obviously copy paste it. There, we followed you there. We followed you on GitHub. Nice. Technical arsenal. Oh, you know everything. Hey, check this out. Python, SQL, Java, JavaScript, C++, R, right? Yeah, Bash, Shell, HTML. You got it. Great portfolio. Good job. Backend developer, intern. Oh, experience. Got it. Nice. Goku, good job. You did it. Quantum engineer. Was quantum on that? Quantum. Oh, whoa. Check that out. You did it, quantum. Hey, I did that too. I built a quantum neural network as well. I did. It was pretty neat. I used D-Wave to do it. I built it like 4 years ago now. Quantum engineer. I know. Isn't that crazy? Hey, Crow engineer. Good to see you. Do you have any tips on learning architecture? A lot of interviews give me a project in the design architecture stack. I think mostly ask the AI, like Quantum was describing earlier. Ask the AI to see if you can build you some training material for architecture. Get Minikube like Kubernetes, right? Minikube, that'll give you the ability to create distributed applications on your local machine. That's a really good idea. So good to have you guys here. Welcome on in. Happy Friday, you guys. All right. Steven taught me about Web Scraper last week. Yeah, that's what we're doing today. Well, we're not doing Web Scraper today. Today we're going to be doing Pytorch. We're doing Pytorch. We're learning about Pytorch. So I'm going to be reading through some of these Pytorch items and be manipulating the matrices. That's what we're doing. Avon Cosmetics, a pink logo. Hey, thank you for mentioning it, Purvis. I didn't know about it. I still don't know what that is. However, I don't see why you can't build it. I think it'd be good. I'd love to learn how to make them from scratch. Yeah, nice. Well, that's what we do here on this channel. We do everything from scratch for the most part. For the most part. Yeah, the Codex and GBA games. Remember those from the beautiful CRT games? I sure do. I'm scrolling through the chat so you guys see if I missed anything. If I miss anything, just type it back in the chat. Sometimes I miss it. You look like the property in Egypt guy. Who is that? Hey, Cute Lemon. Thank you for mentioning it. I don't know who that is, but thank you. Quantum neural network. Yeah, it's real. You can do it. I built it. It is kind of neat. It did acceleration because it can find the global minima. You don't know where? That's what optimization is within quantum computers. It can collapse all possibilities. The way I look at it is like a lattice. with light shining through it, multiple layers of lattices, and you find the one that's the one your answer, the one you're looking for. Either you want to find the greatest value in the final end or the highest value or the lowest value, depending on what you're optimizing for. I think the cathode ray tubes, you got it. Blessed King, thank you. Yeah, Kubernetes are a headache, but when you work, it is somewhat stable. That is a good point. Kubernetes is extra. It is extra. You don't really need Kubernetes for everything. You don't. Hi, Steven. Getting experience. Thought of a pre-final year in engineering courses. Could you help me out? Build something with computer vision. I think that's kind of exciting because it's you can see it. It looks amazing. It's impressive. And then have it be real time. Something real time computer vision-y. What's the theme? Oh, what's that theme? It's Groovebox. Theme equals Groovebox. That's what it is. Theme equals Groovebox. Hey, Chad Envy, happy birthday, bro. In advance? Well, yeah, it's going to be a while. It'll be a little while. So it doesn't suffer exploding gradients. Oh, it depends. You can explode gradients all you want day and night. Doesn't matter if you're using quantum or not. It doesn't. Though it is nice to have it as a layer. That's what I used it for. And let's see. Good to have you guys here. Can we create the LLM with quantum algorithms? Yes, you can. I think so. That's where I think real general purpose, right? General artificial intelligence. That's what I think. That's what I think. Am I early to stream? Yep, you're early. You're welcome on in. You made it. Thanks. You're welcome, you guys. So good to have you here. All right. We're making our way. All right. So for those of you who are here, you don't know me. My name is Stephen Blum. I'm CTO at PubNub. I have a company that's named PubNub right here. Here's the company. We deliver interactivity that users want. This is like multi-user activity. The top 10 apps in the App Store today all have built-in app connectivity, interactions, chat, heart reactions, emojis, communication, collaboration, multiplayer gaming, right? Turning the light bulb on and off on your phone, right? That's what I do. That's what I do, you guys. That's my company. Let me bring my windows back to get the normals going. And later today at 11, if you're awake, or if you're there, I will be live with a podcast with Brock. We're talking about large language models. Large language models. RUX, hey, you made it. No, you're on time. You count as on time. You're good. Chad, how's it going? Should I use AI for learning code? Yes, absolutely. It is a fantastic resource. You're so lucky to have AI to learn to code. I didn't have any of that. I had a book. That's what I had. I had a book that I read in and type and copy and paste and read and type it in. You can do the same, except for you can talk to the book and ask it questions. You can. What's the code here? What are we looking at? What's he creating? Hey, Sarah, thank you for asking. Today we're doing Pytorch. Thank you to Neva for putting this up for us. We're going to be manipulating all the matrices in Pytorch, and I'm curious about how this works. So that's what we're doing. Army, thank you for subscribing. Welcome on in. Good to have you here. You joined at the right time because we're doing Python today and Pytorch. We're doing some Pytorch. What's the stream about? Hey, KTS, we're doing Pytorch today. We're going to be covering all the array matrix manipulation functions. So you can see we're going to do arrange, reshape, random. We're going to do inrand. We're going to see what each of these does, and we're going to go through all of them. Although I don't know if we'll make through all of them because it's a pretty long list. It's a lot. Bro, how to join this LLM webinar. All right, thank you, RUX, for asking. So we are doing an LLM webinar later today. Hope you guys can join. That would be a lot of fun. It's on X. It's right here. Let me paste it in so you guys have it so you can join in. EOS Noon, thank you for joining. Welcome on in. Happy to have you here. Where is the button? It's a clicky show more. Is it this right here? Here we go. Okay. So let me copy this. Let me copy this for you guys. Copy link. All right, post that here. There you go. I'm pretty sure that'll work. Let me double check. We're going to test it out. So what will happen is this screen will pop up and then you click set reminder. You click set reminder and you're good to go. It's not a coincidence. KTS, it's not. Wait, I see. Code on the screen was pre-made by Neva. Yep, you got it. Savon. Pre-made. Many weeks ago now. Many weeks. Where's that at? Here. Let's see here. Is it around here somewhere? Yes, here we go. 3 weeks ago. It was 3 weeks ago and we're finally getting to it. Thank you, Neva. Currently, we have NISQ. We need to make more precision so that it doesn't affect the current quantum computers. I think was a major issue while doing that. You need it soon. You will. Okay, Goku. Well, good news. Well, they're making it better. They're trying as hard as they can. They're making it. They're working on it. Stephen, mind if overwhelming the code with some of the line explainers for the code? Sure. So that's what we're going to do. So what I'm going to do is I'm going to open up a REPL. I'm going to open up the Python REPL. And we're going to be typing these things in directly. And we're going to try to see what they do independently. So each line. So here, let's open up the REPL. There we go. REPL at the bottom. So at the top, we're going to have our instructions. And at the bottom, we're going to have a REPL. Python. Here's our REPL. And then we're going to import these things. What warnings? Wait, I've never seen warnings. What is this? Do you guys know what the warnings? What is that? What is warnings? Let me copy paste this here. V function F2. Paste that. Okay. All right. I'm actually excited about this. Let's get going, you guys. Let's get ourselves some knowledge about Pytorch matrix manipulation functions. Can you get access to the code base? It is, I believe, a public code base. Let me paste it to you guys here on our Discord server. I will paste it to the link threads, the links channel here, link share. Here we go. Boom, right there, link share. This is what we're working on today. This is it right here. Brock crashed for me, never managed to use it. Oh no, that's terrible. I saw it was post on LinkedIn after you stream, and when my internet gets back, thank you, Savan, for noticing the broken link earlier. We found it, fixed it. It's good to go. It's good to know now. LinkedIn, your stream, and when my internet got back. You're good, RUX. You're good. Hey, Chad, how's it going? Good to see you. You famous in Google. Google is saying your company is $300+ million. Oh, hey, Chad. Is it really? You got to show me where it is. Although I think it's more. CAC Picks, welcome on in. Good to have you. Thank you for subscribing. Chad, the number is bigger. It's a much bigger number than that. Brad Jackson, thank you for subscribing. Welcome on in. Happy Friday. I'm so excited to have you guys here. We're going to be doing Pytorch now. We're getting going, you guys. All right. Steven, to be honest, do you know we're smarter than a lot of kids in school, or you found out over time? Yep, you got it. You guys have so much more advantage than what the older people like myself. USA, you got it, Alex. We're in USA. I'm old now, you guys. I'm old. What's up with the energy, bro? I had breakfast. Hoof hearts. Welcome on in. Good to have you here. We're doing Pytorch. Really, that's why I'm really happy. That's why I'm so happy right now. I'm really happy. All right, so let's check this out. So now we've got some Pytorch. We're going to be using the arrange method. Let's try this. All right, so let's type it in myself. All right, so x equals torch.arange. Let's do 10. What does that do? Let's look at that. Okay, so this created simply a single dimensional 0 through like a 10 element array, and it's a tensor. How's it going there, 11 Gaming? Good to see you. Welcome on in. Great to hear that, Hoof Arts. Yeah, thank you. Bro, Steven is awesome. Locked in CTO. Yeah, that's what we're doing. We're locking in, you guys. The infamous. I like your name. That's why his energy is freaking awesome. Yeah, we're making things here. AI was really exciting. Like, what was it? Oh, 2000, like maybe 2014, maybe 13, around there is when I really started getting into AI heavily. Before the frameworks were even a thing. Before they were a good thing. Happy to help. Nice. Thank you, Savan. Everything to support my favorite real-time company and favorite 10x engineer. Thank you, Savan. I don't think you realize how many startups you helped with PN free tier back in 2013. I tried really hard. I wanted to make sure. Who's Todd Green? Todd Green is my co-founder. Thank you for asking, Chat Envy. Todd Green is an amazing person who's done fantastic things. He's done so good. He's the CEO of PubNub. We work together. I love Todd. It's sad because we're so big now that we don't get to see each other very often. And I really miss spending time with him because we've done some amazing things. And it's great. Who's Stephen Blum? Exactly, 11 Gaming. That's me. That's me. So if you know Todd Green, check out Todd Green. So this is me. This is Stephen Blum. So you could also check out Todd Green. Todd Green, he's CEO of PubNub. Amazing person, right? CEO of PubNub. Go follow him on LinkedIn as well. You got to follow him. We've had a lot of fun. We started the company together, and we're making our way, you guys. That's Todd right there. I got confused at PN to see. Yep, you got it, Savan. What platform are we using now? Hoofheart? All right. How's it going there? Nail. Hail NSR. Welcome on in. Thank you for subscribing. So you are owner, Chat Envy. You got it. You got it. Yep. You know it. You know it. You're talking. You're talking. All right. He's an open AI exec. Yeah, ex-exec. Yeah. Luna the Snake. How's it going? Hey, Luna. I like your name there. All right. So this is neat. So there's an arrange function here in Pytorch. Now let's look at this reshape. So what we can do is we can change the shape. So we can change it to a 2x3. We made a 10, so we should do a x dot reshape. Let's do a 2x5. Let's try that. There we go. So now we converted it into a 2-dimensional matrix, right? A 2-dimensional. Wait, can we do more? Let's see. Well, we have to 5, 10, divisibility 9. So 5. This is the best we can do right now. I would like to make a 3-dimensional array. Let's do that real quick. Let's make a 3-dimensional array. You guys, a lot of interviews have been asking to come up with a full stack solution and the defined architecture and design. Any tips on what they're looking for? Distribution, microservices, monoliths. They're talking about how you'd route data between the database, the application layer, the load balancer, the caching layer. All right. Now you're doing caching layer. You're going to CDN in front of that, right? You're going to go bigger. You want to go even bigger? There's so many things you can do there. Jobs typically listed backend jobs as well. So I'm confused when they ask me this. Yep, they're talking about the stack. They're talking about the stack. I wish I could see the shapes. Can you do a 3D? Let's do a 3D. All right, we'll do a 3D. So I need to do a different X. So to do a 3D, let's do 30. We'll do, right, so X now, it's 0 to 30. So it's a 30 single. Let's do a reshape now, X dot reshape. Let's do a 3-dimensional array with 10 elements per array. So there we go, 3D. 3D array right there. Right here on the screen. I hope you guys can see that well. 2x2x3. Hey, Luna Snake, we could do that one as well. You can you do that? Can you do a 2x2x3? Well, I know if you multiply those numbers, that gets you like 12 or something, right? Is that the right number? 3 times 4? No, that's a bigger number, right? 3 times 4 is 12. Oh, I got it right. It was 12 this whole time. Hey, Aiden Arnold, good to see you. Welcome on and happy Friday. Good to have you guys here. You're the third one. You said it. You said it, the infamous. You did. All right, you guys, let's keep going. Let's keep going. Let's see what else we got here. Also, for those of you who are joining in, there is after stream today, we are going live on X Spaces. We're going to be talking about the top LLMs. We've got some pretty neat conversations. So I hope you guys join. I'll paste the link here and again chat real quick so that way you guys know to join here later today. If you're interested, are you 50 years old then? I'm in my 40s, so I am old. I am in 40s. You started your company when you were 17. That was my first company. I've had multiple companies. PubNub was around like 2012-ish or so, around that time. There you go. Aiden Arnold, hello. Oh my God, yes, do a 3D one. Yeah, we did it. Okay, so let's get back over to this. So this is reshape. So this lets us create a new shape or dimension. Now, I bet we could reshape this even further. So can we do 6x5? Let's try 6x5. 6x5. Let's try that. Ooh, look at that. Now it's a square. Is that a perfect square? Let's see. 1, 4, 5. 1, 2, 3, 4, 5, 6. Okay, it's almost a perfect square. It just looks really nice. Oh, I missed your comment. 11 Gaming. Thank you for mentioning it. Let me scroll back up. 11 Gaming. All right. You were really cool, bro. Oh, wow. Thank you. I can't believe I missed your comment. I just saw your channel. I really liked it. 11 Gaming. Thank you for saying that. 11 Gaming 6307. Good to have you here. Happy Friday. This is great, you guys. I'm so excited. What is progressing? Hey, SR Alum. Good to see you. SR Alum. We are progressing on making our way to learn new Pytorch capabilities. That's what we're doing. We're doing new Pytorch. So you can create, if you don't want to do an A range and a rand, it looks like you can do just straight up. You can randomize it and you can give it a different shape. I bet you A range could also be multi-dimensional straight up. I think it is. Is this matrix like from algebra? Aiden Arnold, yes. Yes, it is. You got it. It is. You got it. Absolutely. Which is the best Pytorch or TensorFlow? So Pytorch with Keras. So watch this. TensorFlow plus Keras equals happy and easy. All right. And that's not a thing. So, but however, Pytorch equals more common, more prevalent, equals more people like OpenAI uses it, for example. Anthropic uses it, for example, right? Data structures and algorithms. Hey, we're pretty much, Jack, a little bit. We're doing some data structures a little bit. Pytorch sounds like an FBI operation. Yep. And a fraudulent cake business. It does, doesn't it? You know what? Thank you for the emphasis. Thank you for reminding me. I thought that exact same thing when I first heard about it. I'm like, Pytorch? Hold on a second. It sounds like there's pyrotechnics or piracy or, something's going on there. And there's cake involved. I don't know why it's a cake, but yeah, Pytorch, cake. Because of pie. Because of pie, you guys. Pytorch because it's the most popular one. You got it. Sivan, you know it. And Carpathy, too. Also endorsed it. Nice. So you're a big person. I'm disturbing you with my childish chat. Keep going, Chad. That's what we're here for. If you weren't here, then it wouldn't matter. It wouldn't matter. Just keep on chatting. Reminder is on, bro. Meet you there. Sounds good. RUX. See you at the thing today. So yeah, this will be with Brock. We are talking about the top LLMs worth spending. That's going to happen in about 2 hours from now. Dude, you look 20. Say how you look. Yeah, I'm in my 40s, you guys. I'm in my 40s. I'm old. You guys got to take over. I'll retire and I'll be happy. Jack, he eats healthy. Crow engineer, you know it. You remembered. Yep, got to eat your vegetables, you guys. See you at the X Spaces too, bro. Nice. The Infinite sounds good. And I don't even know about AI, but I'm about to learn. Sounds good. We're going to talk about LLMs. We're going to say different conversations around what we use them for, what kind of features we get out of them. And at PubNub, we use them. We use a lot of them. You know what? I'm actually kind of excited because we're going to have a very uncommon use case for them. Uncommon use case. I'm really excited about that. JPython. We're using CPython. How's it going there, Sam? Good to see you. How do you evaluate an idea that is worth building a product? Oh, hey, well, you know what? You want to build an MVP, right? 2 weeks max. 2 weeks max. Don't go any longer. If you go longer, you've made a mistake. 2 weeks max. Then you present it to users. Thank you for the party poppers, you guys, and the reactions. It's good to have you here. And then you try to get them to adopt it, use it, and then see if it's valuable. And then you pivot from there. And then if you can't pivot anywhere from there and it does nothing, then the product is off the table. If there's value, you're good to go. Skill and Keen in the podcast? I think so. I hope so. That's what we're going to try to do. Are you going to reverse aging? Well, Jack, I don't know. I don't know. I don't think so. I'm not planning on it. Yellow Talk sounds good. Phil Sebo, yeah, still keen to do the podcast. Yes, we're doing, Phil. We're making our way. We're gonna do it right here. We're gonna make it right here. It's gonna happen at 11 in a couple hours. I'm not excited. One day I'll buy your company. Chad, sounds good to me. On the table right now. We're a private company. And there is certain ways that you can get. There's only certain ways. Not right now. Not yet though. Edward, thank you for subscribing. Welcome on in. Good to have you here. Hi to your face. How's it going there? A whole bunch of underscores. Look at your name. Look at your name right here. A whole bunch of underscores. What is that? So look at this. A comma, underscore, and some pretty symbols. Hi to your face. How's that going on? How's it going there? Good to have you guys here today. I'm really happy. You look like your name. All right. Thank you. Reverse aging. Look at Brian Johnson. Yeah, Brian Johnson, the Never Die movement. He's great. I think he's smart. He was the founder of Braintree. I used his API. Founder of Braintree, you guys. How do you recommend learning Python? Start from scratch, Aiden. We had, if you go to, so Steven, here, go to YouTube and you go over to our live section. You'll see here, we did Python basics. Let me zoom into it. See all these Python basic streams here? All these Python basics. We covered every basic that you could think of. By the end of it, you will be more than well. You need to follow along though. You got to follow along. Otherwise, otherwise you got to type it out. You won't remember it. How's it going there, Jaya? Good to see you. Thank you for saying hi. Had your food? I did 11 gaming. You know it. We had the food. How do you recommend Python? Okay, sorry. I'm trying to catch up with the chats, you guys, and we're going to do more Pytorch here in a second. A little bit more Pytorch. There we go. See where we're at right now. A guy already figured out how to live forever. His name was Jesus. Well, I don't know about that. we can't confirm that. We can't fully confirm it. I created just for you, bro. I created a new account because I forgot my username. Did you? Uh-oh. What about Mr. Wonderful getting blood oxygenated? That was a wild thing. It was, right? The infamous. He's trying everything, and then he's measuring it. The most measured human being in the world, right? Brian Johnson. I follow. He's been an inspiration in a lot of my diet and activities. So I think I can attribute some of my health to him. Thank you. He's doing a good job. I think he's doing a good job. Technoblade will never die. I know you're talking about Minecraft, right? You're talking about Minecraft streamer. Never die. Never. He's always with us, you guys. That was sad, right? Technoblades. It was sad. Truth is open source. Frontiers don't have much over the proprietary ones. Yep, but the Kimi K2 broke all the benchmarks, surpassing even Claude. That is pretty neat. I think it's pretty neat. I'm with it. There's no moats, and there's no moats. If you'll sell your company, how much will it be? A lot, Chad. It'll be more than what you mentioned. It'll be more than, because we're doing good. We're good. We can keep going. Like we can choose our destiny now. We've got our destiny in front of us. We don't have anything to behold. Where to get user from my MVP? Oh, wait, Jack, what do you mean? Where to get user from my MVP? What do you mean? I don't know exactly what you mean. Are you trying to type the code from your command, or you see Visual Studio or something? Aiden, yeah. So right now what we're doing is we're learning Pytorch array manipulation functions. So I actually want to try something really quick. Let me try this. So x.arange, x equals torch.arange, and we did, like, you can do 10, right? However, I'm kind of curious. I bet you can do this. Let me delete that, and then I bet you can say, like, let's do 10. Oh, did that actually? Hold on. X equals. Can that work? Oh, it's empty. So wait, that didn't do anything. That didn't do anything that I thought it was going to do. Do we need to put it into a tuple? No, it doesn't like that. Okay. So arange is only going to be, it's only going to allow for a single array, as a single dimensional array. Can we do it like, can we do reshape like that? Can we do like 2, 5? We can. Look at that. You can chain it. Hey, we're learning, you guys. We're learning. Enough with the O2. Can you do some reverse aging for real, bro? I don't know. I think you can slow down, right? Brian Johnson said you can slow it down, but you can't reverse it. Can't keep seeing that too, bro. The infamous. Well, I'm gonna try. We'll see. I don't know. Are you all discussing what is the channel? Hey, how's it going there, Allison? Good to see you. Allison Ramirez. We are doing Pytorch today. We're running through all the matrix manipulation functions in Pytorch, so that way we can learn how to keep an unbroken graph when we're creating our model. It's pretty powerful with what you can do. Currently, how much percentage of AI created code on PubNub, buddy? Well, you know what? I think it's at, I don't know what the percentage is. I should measure that. I feel like I should measure that, shouldn't I? It is quite a bit. We might be at the 50% mark. If that, I think we might be around 50%. So programming is a little hard. Alum, it's hard. It keeps staying hard. Don't worry. It gets fun though. It gets fun. Health is also a matter of genetic luck. I think a bit too. Yeah, I think a bit too. Suggest, can you switch coding screen so your camera, because the screen's hacked. Okay, so Jack, there is a way. I would. So if you guys don't know, so I have been working with Google YouTube on an influencer program that we've been getting together in a group like once every week or so. They said that the layout that you see here is the optimal layout, Jack. And so I've been in a Google Meets meetup with them. They say this is the optimal layout. Only 50%? I mean, I'm guessing. I feel like it's around 50%. So Jack, here's the thing though. Jack, check this out. What you can do is you can open up there's a triple dot icon. Here, let me show you. Well, I'll show you real quick. There's a triple dot icon. Let me scroll. So see, it's kind of hard to see on the screen, but if you click, it's in the top right corner. You click that right there, and it brings up an option list. And then you see right here, there is an option to turn off the chat. Oops, I pressed the wrong button. To turn off the chat, and then you can read it. So it says live chat right here, right there, and you click that. You turn that off, and then the chat. And then you can read it perfectly fine without the chat running, and then turn the chat back on if you want. Turn the chat back on afterwards. That's what you can do. You're from India. Alam, I'm from the United States in Seattle, Washington. It's good to see you. AI will be taking over. Don't learn. It's a waste of time. Hey, it's not a waste of time at all. I don't think so. It's definitely not a waste of time. Let's see. Learn tech space right now. Everything is able but overwhelming. I'm going to go into AI space. How to start. This is a good starting point. We're doing the basics for Pytorch right now. This is like the very basics. We're doing the ultimate basics right now. Isn't it neat? Look at that. Oh, it's so good. All right, let's do 50 and then see what that. Oh, yeah, you got so 10, 2 by 10. That should totally work. Oh no, 5 by 10. There we go. So this is a way. And then can you do rand? What was the rand? Rand in? There you go. So now that's how you initialize the proper matrix right here for a layer. Look at that. Oh, that is so good right there. Oh, so good. This is a very powerful way to initialize a matrix. When you're creating layers, this is actually a pretty good distribution. It's pretty good distribution there. Hey, if I miss your chat message, just let me know. I see some going on the screen and I might have missed. The optimal layouts for gaming audiences that I think for people or on TV or something. Yeah, so we do have, so we are on Twitch and LinkedIn as well. So we're live on LinkedIn. So you just scroll over here and you scroll down to this. You click on the, you can see here. So if you want, there's a different layout. So it's easier to read. It's easier to read, you guys. Easier to read if you want to do this. So, and then we're also on Twitch as well. So you say twitch.tv/StephenLB. And then you can see us over here as well. Hey, no, there's some Inception. Check that out. That's pretty neat. Yeah, it's pretty neat. It's good to have you guys here, though. I'm here for YouTube. YouTube is my platform. It's my platform. YouTube is the primary platform. Hi, data structures and algorithms via chat. Okay, 1 second, you guys. I got a poll. So, let's see. So, question. Lock in on Pytorch or read more chat. All right, so Pytorch or more chat. All right, let's see what you guys say. See you guys doing a poll, a quick little poll there. While you're voting on the poll on what we're going to do next here, I'll actually read some of the chat. Can you resize the console view a little bit better so I can see the far left? Oh, it's okay. You don't really need. There's nothing over there. there's not much over there. I see it on my screen. It seems perfectly. I can see it. Like I can fully see it. Like I'm on mobile right now too. I don't know if you can see it very well, but I see every pixel. It's kind of blurry, but yeah, I see all the pixels. Every pixel showing up on my side. I can zoom in a bit though. What I could do is zoom in for you. Let's zoom in a little bit more. There. That might be easier to read now. A little bit easier for you guys to read. All right, Pytorch. All right, you guys, we're going into Pytorch. 92% on Pytorch. All right, so I might miss into your all's chat. How's it going there, Sir Cats? Good to see you. Hello. All right, bro. Same here. Could also curve screen. I have a curved screen too. All right, so don't worry. It's not going to be. There's not too much on the side of the screen you're going to worry about. It'll be fine. It'll be fine, and we'll just indent so you see where it indent. All right, now we're going into Pytorch, you guys. Fix my screen. You can see. Nice. Zoom in. There you go. Perfect. All right, so let's go into the next one. All right, so zeros. All right, that's a pretty neat one. Torch.zeros. You can give it. So let's do 10 by 10. Let's do 10 by 10 zeros. So this will just initialize a matrix that is everything's fixed to 0. You don't typically want to do this very often. Yeah, I don't know when you would want to do this. Hey, what are we doing, sir? We're doing a Pytorch. So those of you who are just joining in, my name is Stephen Blum, CTO of PubNub. So we're going to do some Pytorch here, and we've got a lot of devices on my network. I've got all patents, and we've been doing this for 25 years. Well, actually longer than 25 years. And what we're doing right now is we're doing Pytorch. Oh, check this out. You can do ones. All right, so you can say torch.ones. We'll do like 5 by 5. And then you can initialize a whole bunch of ones. That's pretty neat. So we got ones, zeros, randoms, and an A range. Torch.A range. We'll say 10. You can do, let's do 100. Yeah, let's do 100. There we go. Take a look at that. So, and then you can say dot reshape, and then you can do like was it 10 by 10? 10 comma 10. There, now you can make a perfect square. Well, sort of. Why are you so perfect, crying face? Hey, I don't know what you... I'm going to take that as a compliment. That's what I'm going to do. I'm going to take it as a compliment. It's good to have you guys here. Anthony, what you do? We are doing Pytorch right now. We're going through all the different array manipulation functions. All right, so let's make a new, a 3-dimensional random. All right, I'm going to type this in, you guys. So we're going to do this one right here, this line. So it's torch.rand, and then you can do 3 dimensions. So I'll do 10 by 10 by 10. What's that going to look like? Explodes on the screen. Let's make it smaller. Let's go 2 by 2 by 2. So you can see it, actually 3 by 3. So it's more symmetric. There you go. So this is a 3-dimensional matrix, you guys. 3-dimensional matrix. Thank you for the party poppers, you guys. Currently software engineer intern looking for a Solus full stack project. Nice. You're on your way. Any tips? Yeah, Python and JavaScript are really good places to get things happening. Let's do something impactful. Joe, I'm with you 100%. We could cover lessons. We're basically doing the basics is what we're going through. We're looking at all the different matrix manipulations. So there is a torch.tensor here, which is going to convert an existing Python array into a tensor. So let's try that. Before we do that though, let's look at shape. So let's do this. P.shape is going to give us the dimensions of the array. It's going to give us the dimension. How is the 3D representation? Well, you can see it's 3D. It's essentially it's a cube. It's a cube. If you sort of draw these all at a point, right? So we do it's just a scalar draw here. If you draw these at a point, so I don't see how we can draw that. So can we draw this? So we've got like a cube. So you got each of these at a point, right? So I'm going to draw this, and you've got your first layer up here. This is the top layer of the cube, right? Each point is a floating point number, and then you've got another face here. Let's do this, another face here on the cube, and then another face here, and then you've got another face on the side, and you can see that kind of like that. So, but a little bit different. There's like you can see on this. That's a cube. I hope that made sense to you guys. I don't know if it did or not. I don't know if it did. What's your view on Go? Go is a great language. Go is great. Compiles very fast. And in fact, the founder of Brock will be on with us live for the LLM agent. Loves Go. Go is like a really favorite language, a very favorite language of theirs. Right? So that will be Jonathan. Jonathan here. Favorite language is Go. We'll get in some Go channels, right? We'll do some colon equals. We got some colon equals, right? Doing some colon equals. A lot of colon equals in Python and Go. What about HTML5? Alum. That is a word that's been around for a while. Thank you, Stephen. Hey, you're welcome. What's your, so Go, I love Go. Go is great. And some channels, we could do some channels as well. Some if-nulls, some if-nils. If-nil, got a lot of if-nils in there. So each line is one coordinate. Pretty much, yeah, exactly. Pretty much. Sivan, actually, oh wait, Sivan, of course you know this. You know this, Sivan. All right, so shape, what is permute? Okay, this is what I want to know. What is permute? Let's learn about permute. Permute reorders dimensions like transpose for more than 2 dimensions. Okay, so we can't do reshape. What is permute? Permute might change the layers. So let's try this. Let's try it. So p equals torch.rand. We'll do exactly 2, 3, 4. So p looks like this. So 3-dimensional. Then we do p.permute 1, 0, 2. What does that do? That is difficult to read. That is difficult to read. What did it do? So 4, 2, 6, 5. It seems to okay. That is difficult to read. I wonder if we can make that a little bit easier to read. So let's do 1, 2, and 3. And then we'll do permute. Let's try that. Okay. So P and then P without permute. So let's do another permute too. Okay, so what does this look like? So we're looking at this part of the screen here, you guys. Let's take a look. 8, 4, 7. This is 8, 4, 7, 9, 3. I don't know when I would ever use this. Do you guys know? When would you use this? M. Jacker, thank you for subscribing. Welcome on in. Happy Friday. Good to have you here. You guys, this is kind of neat. I'm proud of him. Any tips for placements? Hey, Soul. Hey, Soul's Pity. Poity. Soul's Poity. I don't know what you mean by that. I don't know about the placements. What do you mean? Let's see. Thank you, Steven. You're welcome. Let's see here. How's it going, Monkey D. Luffy? Good to see you. Welcome on in. Happy Friday, you guys. All right, so I don't ever know when I would use permute. I really don't. It's like transpose. I get that part. So P dot T. So you can transpose like that, and that just sort of pivots the matrix, right? So it does a pivot. It takes the matrix and then it rotates it. That's what transpose is. Aiden does games. Thank you for subscribing. Welcome on in. Good to have you here. Happy Friday. I'm so excited. It's like rotating axis. Is it? Okay, so I get that part. Can we do 1, 1? Doesn't like that. Can we do 2, 1? Okay, so that makes more sense. So P. So C, that. Okay. So it's, you can choose where it rotates. You can choose where it rotates. Thank you for the party poppers, you guys. Appreciate it. It's like a regular transpose switch for X or for Y. Got it. Okay. Got it. Understood. All right, so let's see here 1 second. We say, love where you're from. Learn to go, like learning meaning fully utilizes the multi-thread architecture. Most no go, but don't utilize it. Multi-threading, channels, message passing. Yeah, Jack, you got it. That's the way. That's my favorite for concurrency. How's it going there, Piston? Good to see ya. Currently in college, pre-final. Any tips or guides on a landed job? Build an app, release the app, get users to adopt the app, and then talk to the users, expand the app, grow, and start monetizing it. It will put you ahead of your competition. All right. Can you show me some pipeline option for a model which you created? Oh, we are not quite there yet. We're not quite there. We're just going through the matrix manipulations. All right. So I know this one's pretty easy. So we say standard Python array, right? So we'll do a standard Python array. 1, 2, 3. We'll do a standard Python array, 2-dimensional. Salah, thank you for subscribing. Salah's page is here, you guys. Welcome on in. Happy Friday. 4, 5, 6. So this will be A, so standard A. And then you want to convert that to a tensor. Torch.tensor, and we'll say A. And then that will make it into a tensor. What that does is it prepares it for the graph to be sent to an accelerator. That's what the tensor's for. That's what the center's for. Monkey D. Luffy. Yeah, eventually we'll get there. Right now we're just doing matrix manipulations. We're doing the very simple things. It's necessity for a product, Stephen. Got it. Okay. When you're doing some products. What are you currently building, brother? Hey, good question. We're walking through all of the Pytorch array manipulation functions. Essentially, when I say array, they're matrices. And when I say matrices, they're also called tensors. They're all the same thing. They're the same word for the same thing. Look on this, right? See it's on the screen right here, right now? On the screen, what I'm highlighting? So you see right here, that is array, a multidimensional array. This is, right next to it, is a tensor. And also, it's called a matrix. What does it mean? Oh, the same thing. It's exactly the same thing. Dot product. Yep, I know. Yep, dot product. Dimensions must match back to the linear algebra. Got to match those dimensions. You definitely do. Course on wave mathematics. Stuff pretty neat so far. Image manipulation coding. Very, very useful. You got it. Tensors in dimensions. Hey, the cookie. The cooked. Good to see you. Hi, Steven. How's it going? Good to see you. Welcome on in. I'm going to go watch your previous lives on Python Basics. Sounds good, Aiden. All right, let's look at the next one. So let's do order of position. What is this? I. Ooh, that's a neat one. All right, torch.I. Let's do 10. You can see here on the screen that it's a diagonal ones. You see the diagonal ones here? Right there on the screen. See, and all the other numbers are 0. So that creates an I. See, torch.ones. Right, you can create a 2-dimensional 3x3 matrix with ones, which we did earlier. You can also do zeros. Oh, and you can directly index. Check this out. Look at this right here. You can directly access the index right there. Right there. All right, let me see and pull. There we go. What is use of PubNub? Chad. All right, real quick for you guys who don't know, this is my company, PubNub. We've raised 134 million Series E, over 1 billion connected devices, 68 patent claims granted. We are communication for in-app experiences like transportation and logistics. When you order food, you see the car on the map approaching you. That's my company. If you're doing betting and gaming and casino, you can do multi-user experiences, right? Live sporting media updates. What's the score? What's happening right now? What are people talking about? Multiplayer games where you compete in digital telemedicine. That's what my company does. That's what the use of PubNub. So many use cases. You need so much communication out there. We do a lot more than communication though. That's just a foundational feature. Thank you for asking about that. And today, for those of you who are in here, we are building a podcast discussing large language models that will be in about 1.5 hours from now at 11 a.m. At 11 a.m., I'll paste it in the chat, you guys, so you can join later today. It'll be a podcast with the founder of DataStax, and who's now started another company called Brock. Very exciting. Also Paul from F5 will be there as well, and we also have Dylan who will be there. It's kind of exciting. I'm really looking forward to that. It's today at 11 for those who are interested. We'll be doing a podcast today. Do you have a building of PubNub? Chad, we have multiple buildings. Yeah, I think that's what you're talking about. Is it possible to look and be 40 and old? I see what you're saying there. Laughing goat. You're talking about me, aren't you? I know what you're saying. I know what you're talking about. Identity matrices. Yep, you got it. All right, so let's mess around with this more. All right, so you see here, we've got 1, 0s. You can also directly access the index of a multi-dimensional array with this approach here. So you can see this right here. Check this out. This right here is pretty neat. I like this right here. This is pretty neat. So let's try that. Let's mess around with it. All right, so let's do zeros. Zeros. Like that, a 3x3. So A equals, let's copy and paste this. And then A is 0. So A, we'll put here's what we'll do. We'll do the very middle. We'll convert this to 100. We'll make that like into 100. So we'll do that. All right, so what we do is, so that is line 1, 1 is going to equal 100. Did I do it right? I don't know. Let's find out. I'm actually kind of curious. Hey, the Wahab, good to see you. Welcome on in. All right, will the matrix be correct? Bangarang. Whoa, Bangarang. Hook? Are you talking about Peter Pan? Is that what you're saying, Ilf? I remember that movie. Robin Williams. Why do you look like Mr. Beast and Peter Parker at the same time? I don't know, Monk. Mango Tree 2384, 23824. I don't know. Good to have you. Welcome on in. Good to see you. Welcome on in, you guys. Happy you're here. Please, I'm new to Python. How is this going to help me? It will, if you want to learn Python, at least being aware of what's possible is important. You might not remember it, but you know what? All right, let's see. Did we do it? It's the middle 100. We did it. Hey, we know what we're doing. Check that out right there. So A was originally that, and then we converted it to A with 100 in the middle. All right. So that's pretty neat. I did not know you could do that. That is pretty neat. Oh, we can do a matmul. Are you guys ready for a matmul? Do you guys want to do a matmul? Yeah, you do. It's one of the coolest things you can do in Python. It's one of the coolest things. Hey, Amzad, Hussein, thank you for subscribing. Welcome on in. Good to have you. Happy Friday. Glad you guys are here. Let's see. Would you recommend always defining the return type in Python functions? You can do it. It doesn't do anything. It only is necessary if you do a linter and a type checker. Bro, what you can do is just use Claude. I know, right, Marcos? You don't need to do this programming stuff anymore. You can just use Claude. If you guys want to do that. I know, right? Is this like an old, outdated skill is what we're currently looking at right now? Is that what we're talking about? Is it like back in the day when there was hunters and gatherers, and now that job doesn't exist anymore, right? That job is nowhere in the world. You don't have that job anymore. That job does not exist. It's done. Is that what coding's going to be? I think so. I don't know. We'll find out though. We'll find out. All right, let's keep going. So let's do a matmul. All right, so we've got A. We can do A at A. And that's going to matrix multiply that. Let's do A dot, let's do A equals torch dot rand. Well, no, that's too hard to see though. That's way too hard to see. Let's do A range. Let's do A range is easier. A, so let's do A dot, let's do reshape. Let's do reshape dot reshape. We'll do 2,5. So it's a two-dimensional array, right? Two-dimensional array. So can you do A at A? We got to do A, we got to transpose it. You got to transpose it, right? Is that going to work? Will this work? All right. When I press enter on this line right here, do you think it'll work? I'm actually going to ask you. You look rich, Mango Tree. I will take that as a compliment. Thank you. Bangarang. Let's see here. So let's do a quick little poll here. Will this work? All right. Start a poll. Error or success? All right. Will this right here on screen, this part right here, that part right there, error or success? I think success. Is it going to be error? Immediate error. I don't know. Will it be error or success? I don't know. I feel like that should work. My experience tells me that it should work. It should. Yeah, maybe. One of my friends are dyslexic. I feel bad, so made a Chrome extension with tons of dyslexia-friendly fonts. Should I pay the $5 to release it? Yeah, absolutely. Make it happen. Help the world. Help the whole world. I just saw the video of you showing how to create a group chat. I thought it was funny when you were creating an account on the PubNub website and it asked for a special character, and you thought, Aiden, that it would let you create an account. You never. I mean, we did our best. How's it going there, Roberto? How do you feel about coding and test coding? Yes. So, have you heard of test-driven development, TDD? All right, you guys. Let's see if this works. All right, let's paste that in. Here we go. Is it gonna work? It worked. For those of you who said success, you got it. Thank you for the heart, you guys. That was a success right there. You got to do a transpose. Transpose is the way to go. Otherwise, it gives you an error. Or what you could do is just set up A.A range. We say that to like 30, and then you can say dot reshape, and then you can say, you can do like a uniform, right? You could do uniform. So how do we do that? Is that, maybe let's do 100. Let's do 100. So we 10 by 10. So it's a perfect square. It's a perfect square. And I got to type it properly with an equal sign instead of a period. And also got to add the torch in, right? Torch dot, there we go, A. So we can do A at A. That'll work now. That'll work because it is the right shape, you guys. It's got to be the right shape. It would let you create an account. Yeah, if you feel about coding as test coding is good. I like it. People who don't have a domain, just admiring localhost. Elf, that's the way to go if you don't have one. All right, you guys. So this will give us a very big matrix that goes huge. So can we make this smaller? Can we do 3 by 3, and then we do 3 by 3. A. Then we do A at A. Since it's the same size in the dimension when you're multiplying it, it will succeed. However, if it's asymmetrical, you have to transpose it. A at A will fail. So A dot T will transpose it. And now your matmul will work successfully. It'll work successfully, you guys. You can also do addition and multiplication. You don't have to do, so you don't need to transpose, I don't believe, for mults. Do you? No, you don't. And dot transpose won't work in that case for a multiplication. However, you can say plus A. And now you've got a whole different matrix right there. Hey, Itzer, good to see you. Welcome on in. Memes dropped, RUX1000, thank you. All right, good to hear. All right, you guys, let's keep going. Let's learn some more. Gradients in Autograd. All right, let's try it. Requires gradient true, tensor. So let's look at this. What's going on here? Let's type this in. X equals torch.tensor 2, comma, requires grad equals true. What is that? Oh, it needs to be a float. So you got to put a period right there. Got to put a period, otherwise it won't work. Okay. So y equals x times, to the power of 2 plus 3 times x. Y. And then it adds a backward. Oh, look at that. That's neat. I didn't know you could do that. It auto computes the gradient. A backward gradient right there. All for us. That is pretty neat. All immediately. That is powerful. I didn't know. Web browser and Scratch stream win. Yeah, right. Like we're gonna build a whole web browser in the Scratch programming language with the drag and drop, if, else, and thens and while loops. I don't think so. I don't think so. Are you kidding me? I know you're joking, right? You're joking. You're playing. Or are you serious? You never know. Marcos David, thank you for subscribing. Welcome in and happy Friday. Good to have you here. We are doing some Pytorch today. Oh, we can do a backward. Check that out. Y dot backward. Okay. And then what does that do? I don't know. What did that do? Computes the dy divided by dx and stores it in the gradient. Got it. Okay. So this supports backward propagation. You want this when you're doing training. When do you not want it? When you're doing inference, right? You guys, when we're doing inference, you don't want back propagation or gradients when you're doing inference. How to be consistent in coding. How's it going there, Rock? Good to see you, Rock. You will be building regularly. It's like exercise, isn't it? It's like practice. It's the same thing as practice. Are you being like e-gaming, right? You got to practice a lot so you can compete. You're doing actual sports, like physical real-world sports. You got to practice. Are you trying to keep up a skill? It's the same as a skill. You gotta practice. That's how you get consistency. Can you explain the @ symbol on Python? Yeah, absolutely. Goku. So the @ symbol is a matrix multiplication. What that's going to do is it's going to sort of do a multi-dimensional for loop for you. So it's like doing a multi-dimensional for loop. So let's look at this. All right, so X. Let's do A. A, okay. A is good. All right, so you can say for X in A, print here. So print X, comma AX, right? So, oh wait, did I do that one for X in A? That should, oh, right. Okay, so there's multiple indexes. That should work though. That should work. That should bring us back. Let's just print X. What is X? 1 second. X. 1 second. Got to make sure I don't get those typos in there. Okay. Oh, X is going to be the actual tensor itself. Okay. And then you say for Y in X. And then you say print Y. Print Y. There you go. And then it's going to give us all of these tensors. And so what's happening here is with the @ symbol, right? The @ symbol is going to be creating a new matrix that is going to be multiplying the previous matrix. So it's an A matrix multiplication. A will essentially create a for loop nested that's going to return a new, let's see, A, hold on, A. Oh, that's not the right shape though. So wait, we need to make the right shape. So A, let's do, please tell me the website to practice for JavaScript, Rock. Actually, that's a good question. I don't know. W3 Schools is a pretty good one. Use pinging mood. It lets Scratch connect to the web. Oh, really? I didn't know that they had a built-in request model. So good to have you guys here. We're doing some Pytorch, you guys. Let's explain the at symbol right here. We're going to do that right now. So let's recreate the matrix multiplication. Let's recreate it right now. So def matmul, and you say x comma y, and that's going to be so these are the two matrices, right? So for x so for actually let's do a and b. Let's do a and b. I think it's better. A comma b. So two matrices for x in a, and you do for y in a. Now you've got, actually we need to enumerate it, because enumerate, I need to access the independent elements directly. Do I though? Do I? Yes, I do, because I need to be able to reference enumerate a and do y in enumerate a. Let me do print x comma y. I need to make sure this looks right. Def matmul x. Oh, did I do too much indentation? Oh, yeah, I didn't. Let's see. Here's the error. We gotta type 4 right here. 4. Then we gotta indent. There we go. And go there. Okay. So that is matmult. We put a comma a. And that's going to enumerate through the tensors. That's going to enumerate through the tensors. All right, so it's going to give us x and y. And then we can go. W3, what's that? W3 Schools? Have you not heard about that? W3 Schools is one of the places that's actually pretty decent for JavaScript. Bro, how much I missed? Eyes for gaming? Hey, don't worry. We're recreating the matmul, and we're just working through it right now. So we're trying to do really simple matmul. Enumerate should have given me. Here's what I'm going to do. Let's create a different file. Let's go here. Vi mat. So I can get Vim. I need my Vim motions. Matmult, mult.py. So that will be. We'll just do. We won't do tensors. We'll just do regular arrays. So a equals 1, 2, 3, 4, 5. Let's just do 3 by 3. So we'll do 1, 2, 3 like this. We'll indent that. Copy, paste. Increment to 4, 5, 6, 7, 8, 9. 7, 8, and 9. All right, there we go. This will be our array. Here we go. So that's A. Print A. Let's double check that works. Python matmult. Wait, the matm matmult. Oh, did I not save it? Oh, I'm in the wrong direction. CD Python mat. There we go. Okay, so there's that. Rock make cheat sheets. Right? How's it going there, young shovel? Young shovel, good to see you. I'm pretty good at Scratch Coder. I sent you my project. Did you, Ilf? I'm actually kind of curious to check that out. I think that would be a lot of fun. Bro, how do you know all of this stuff? Rock, we just years of practice. Your practice, and I'll try to show you what I got. But we're getting into the basics here, you guys. Hey, Steven, what language was PubNub built on? C. The C programming language. And now we are migrating to Rust. We have a phenomenal team at PubNub who are fantastic engineers, and we are right now migrating a lot of our stack over to Rust. Thank you for the hearts and reactions, you guys. It's so good to have you here. We're gonna recreate the matrix multiplication. So def matmul, and we'll say a comma b. So for x in enumerate a, and then we'll do y. Indent that. And we'll do print x comma y. I need to double check what this is. All right, so let's go over here. Let's run this function now. We'll say matmult a comma a, and then we will print it. We don't need to print right now because I already have that here. I have it here. So we're debugging it. We're going C and EPL. Yeah, you know it, Stefan. You remembered. C and EPL. If you guys are not familiar with EPL, it is a Linux kernel module that allows you to implement cooperative multitasking, essentially, a way to fully leverage the entire CPU without any pauses, leveraging the operating system to give you interrupts when there's network I/O that needs to be essentially processed by the user space application. It's so good. It's the only thing that you guys you need for hyperscale. It's what you need for high. Can you play my project on stream? Ilf, actually, we might have some time here. We might have some time. So we do have some time. We're not going anywhere yet. So good to have you guys here. We're going to recreate the matmul and then remind me, and we'll do that. And we'll do it, Ilfs, okay? What you recommend for the newest intro to programming world? Python. Always Python is a really good place to start. How should I study software architecture in Linux and OS for the interview? MD, you want to study, all right, so things like this. So you say you want your let's just do the stack. Let's do the full stack real quick. All right, so architecture. Typically, you're going to have things like a load balancer, right? It's a good starting point. You're going to have your microservice / API, and you're going to have your cache layer. You're going to have a database, right? Like a post, right? Or you could do PostgreSQL / MySQL / SQLite. Probably not SQLite right there. You might have SQLite here though. SQLite over here. And then you will have maybe some security rules, sort of like different CIDR rules, right? 0.0.0/32, something like that. Networking security in there, probably more at this layer. Load balancer, microservices, cache like Redis / memcached, things like that. So this is a good start for architecture in that conversation. I do believe, right? Probably Nginx / or you could also do, Pingora, things like that. What kind of project you do? Hey, Jack Newman, we are currently building a matrix multiplication so that way we can show you guys what that looks like. All right, so let's print that. Let's do this here. Okay, so that does basically what I'm looking for the most part. Let me double check. So let's see, x1 comma x, y1 comma y. Let's double check that. Okay, yeah, now we got it. Is that it? Okay, so that's 1, 2, 3, 4. That's the actual values. So that's the actual values. The index, right? The index is what's going to be x1. So let me see. x1 comma y1. Let me double check here. Okay, now there we go. That's what I want. That's what I'm looking for. Perfect. Okay. So this will give us the index. And now what we can do is we can use that to the actual matrix multiplication. So this will be the new matrix. Like that. All right, so this will be the row equals, and what we should do is, we should probably do list comprehension, what we should do. Row equals, so we'll do a row here. So we're gonna keep it simple, Here we go. Row dot append, and we're gonna matmul. So we'll do let's see here, x1, comma, x2, I think, times b, or wait. Is it y? Yeah, it's x1, y. Okay, and then we do x1, comma, y1. Decrement that. I think that might work. And then over here you say new matrix dot append row. There you go, like that. That might have done it. I think maybe we're gonna find out, aren't we? We're gonna see if that works. Do you use Facebook or so whenever I get a problem? I use Instagram or Discord if you guys are interested. How's it going there? Olam, hey, thank you for saying. And also, hi from Spain. Good to see you. Hey, Kevin McAllister, I just saw your message. How's it going? Good to have you here. Hey, Kevin, if you're interested, we have a podcast that's going to come up at 11. It's going to be in about an hour from now. And we're going to talk about large language models. It's going to be with Jonathan Ellis, the founder of DataStax, who's also the founder of Brock. We have Dylan and Paul from F5, and we'll be live at 11 on X Spaces. So if you guys want to join, I'll paste that link for you guys real quick if you want to join. That's later today. I hope you join us. Be really excited. Discord link. All right, let's do it. Let's grab the Discord link just for you. All right, let me grab that over here. Copy the Discord link for you. Copy that. All right, so that is for you, Rock at Rock. Discord link just for you. Pretty cool. Yeah, I think so. Kevin McAllister, thank you. I'm excited about it. We're going to have a lot of fun. We're going to talk about large language models. And we use them at PubNub. We use them pretty interestingly. We've got some specific requirements that we use them for. Thank you for the hearts, you guys. Appreciate it. What do you prefer, MVP of startup, traditional code, web app, or a low code, no code AI built quickly and what's PSC? Low code, no code is a great way to do a prototype. Prototype is great. And if the users can use it, you're good to go. It doesn't matter if you build it yourself or if you use a prototype. Either works now, PSC. You got it. You're good to go. What does the multi-dimensional array represent? It is going to represent a series of coefficients that will be used as a way to track how to manipulate numbers from input. I'm just going to say a whole bunch of words here. For artificial intelligence. There you go. It's for AI. That's what it's for. We're doing AI, you guys. I'm so glad you guys are here. Thank you. Thank you, Rock. Might want to get pretty later here. I know. Would it be recorded? I don't know if it's recorded. I don't know. I think it is. I think it might be. Awesome. We'll definitely check it out. Excellent. Thank you, Keller. Sounds good. Also, is there a way to do matmul without double loop? Yes. Yes, there is. There is. You got it. We can do that. We can do it with a single loop. You can do it with a single loop. We're just going to try this for now, though. Let's see. Python. All right. A, comma, A, matmul, A, problem. Did I type that wrong? Nope, that's there. Print A. Okay. X1, Y1. List indices must be integers. All right. That's because these are... Let's see. Let me just check that. So I think what we have to do is this. I was thinking Pytorch. You got to do it like this. There you go. Like that. Now is better. And there we go. Check it out. I know what's going on. There we go. Return new matrix. All right. Print it. All right. Did we just do it? Yeah, we did. Look at that right there. Now we got to make sure that it's correct. Let's validate it. Let's validate it, you guys. Let's validate it. So that's what the @ symbol does. All right. So import torch. And then we'll say a tensor, right? A t equals torch.tensor a. Let's see for that. We'll say t. All right, so print t. I want to double check that this is going to work. Print, thank you. T looks good. Okay. Is that going to, yeah, okay, good. So that created the tensor right there, you guys. That created a tensor. Hey, Keller, thank you for subscribing. Welcome in. Good to have you here. Happy Friday. I'm having a lot of fun with Pytorch over here. This is important for artificial intelligence, you guys. This is a precursor to today's podcast at 11 a.m. here in Pacific. Hope you had a good day so far. I did, Tiny. Thank you. Awesome. Definitely checking it out. Sounds good. See, can we ask what type of large language model related questions, or are you the one asking? Hey, Eyes for Gaming, ask any question you want right now. During the podcast, I don't know where it's going to go. I've not done one of these style of Clubhouse style podcasts before, so I think it's going to be a group discussion. It'll be a group discussion. I'm kind of excited about it. I won't be this bombastic during the call. It's going to be more professional. So if you were... Hey, Anime Andy, thank you for subscribing. I like my anime. I watch a lot of Crunchyroll every day. I watch Twitch. I watch Crunchyroll. I watch streamers. I watch YouTube. That's what I do, you guys. I don't know if you do. That's where I'm at. Let's see here. I wonder how Pytorch implements matmul. Might be fun to take a look at that. Yes. Kevin McAllister, I think you're talking about it the right way. So it's done in a kernel for the GPU. I've written one myself. And it is done exactly like you described. Because it's a multi-thread, you do not do a for loop. There's no need for it. You don't need to do a for loop. There's no for loop. It's not there. It's done in the kernel because the threads are already done in parallel. It's so neat. I've built it before. It's great. Hendra, thank you for subscribing. Welcome on in. Good to have you here. Happy to have you guys here today. Oh, what? It is. It's really neat. It's great. Try building your own GPU kernel or accelerator kernel that has concurrency built in. It lets you reference the memory of the matrix, essentially a texture, right? So you've got your texture. I don't know how to say this. You've got your texture here. So let's clear this off here. So you've got a texture, right? And then you've got, let's do 6. So you got your 6 here. So you got your texture, which basically represents a whole bunch of pixels, right? I'm trying to represent a bunch of pixels. What I'm doing. Here's a grid of pixels. And you get each one of these coordinates is a core. And when the core executes, it gives you where that core is executing its X and Y and Z coordinate, right? Because it's 3-dimensional core. You can use that to reference what you're multiplying, and then you return the output of the final matrix multiplication. It's exactly like you're talking about. You've never written a kernel? You should. You give it a chance. It's really neat. We'll learn something new. Yeah, Steven, we need a stream average out. Wait, Savan, tell me more about that. Oh, the hardware does it for you. It does. You got it. It does. That's so cool, isn't it? All right, let's see if we can do this ourselves. All right, so that's matmul. And then what if we do print t at t? Is it going to match? Did we do it right, you guys? Are these lines going to match? Are they going to match? I'm actually really excited about this. All right, so this is high stakes here. If I got it wrong, then it's like, Steven, what are you doing? All right, did Steven get it right? All right, did Steven get it right? Question mark. Yes or no? Did Steven get it right? Is it going to crash? Will it work? What you see here on screen right now, this section right here, what we're looking at right here, this section right here, you guys, that part right there, is it going to match? That's what I'm looking for. Is it going to match? I'm so curious about that. Ilf, what are you talking about there? You got some long, it looks like, I don't know what you got there. I don't know what you pasted in there. Let's see here. It looks weird on my screen. It looks weird. So here we go. Looks like a whole bunch of binaries and GPG, tarball, some signatures or something. I'm not sure. Something like that. Some builds of some type. We need to stream about CUDA. About CUDA, right? Kernels. I see. That's what you mean. Okay. Okay, that'll be a lot of fun. Let's build some shaders, you guys. Some compute shaders. I don't know. Trust in Steven. All right, I know, me too. Hey, Brock AI. Hey, Steven, looking forward to that chat later on the stream. Yeah, exactly. We've been telling people about it. All right, you guys, Brock AI is here. No, don't delete Brock AI. They're real. They're real. All right, sorry, Brock AI. Your message got redacted. I don't know how that happened. You know what, though? It's real. So, hey, you guys, there's a link directly there. We're going to be live at 11 today. Hope you guys to be there. We're going to talk about our large language models with Jonathan, founder of Brock. Hey, Steven. Hey, Dylan. Hey, Steven, looking forward to our chat later. Great stream today. Yeah, thank you. Yep, Dylan's here, you guys. So here, we're going to be live today here on X, the X platform. That's Dylan right now talking in chat. Right there, Dylan. Sorry, I want to be in my account. Sounds good. All good. We'll be with Jonathan Ellis, founder of Brock, also DataStax. And then, of course, who's that guy, right? And then Paul from F5, principal architect. We're going to be having a chat on X later today. Excited to see you guys. And that link that I just pasted there into the chat, that'll be with us on X. I'm excited. Sure thing. You wondered why it got redacted? Yeah, me too. I was wondering too. So that's the plan for today. Set the reminder, you guys, in 1 hour. In 1 hour. If you're going to act professional, it can't go. Sorry. I know, right? It can't. All good. Need to make that poster with the GIF with moving faces. You have the moving faces. Yeah, exactly. Is it going to be on X Space? Yes. This is on X Spaces. All right, you guys. Let's see if it works. All right, let's see if I know what I'm talking about. All right, here we go. Does it work? Close enough. That's definitely not the same numbers, but it didn't crash. It didn't crash. It's because I don't think I rotated it. I didn't do a transpose. So here, I didn't transpose it. Now it's still different though. It doesn't matter. Okay. So let's see here. All right. So now let's see if I did something. Something worked there. All right. Here's what we're gonna do. We're gonna see if we can get it closer. Let's see if we can get it closer. All right. Professional. Yep. Exactly. Professionalism, you guys. Doing well. Thanks for asking. Nice. All right. So let's see here. Let's see how we can get it to match up. So I got it close. I mean, we're not too far off. We're not too far off. So let's go over here. Let's close that out real quick. Let's see if we can fix this. Let's see if we can fix this. All right. So we need it to be 30, 36, and 42, which means that likely what we need to do is YX, right? X1. Let's see if that works. Let's see if that made a difference. That might have been all we needed. Is it? No, is it? I can't. Hold on. Let me see. I'm printing too much out here. Let's close this. Print. Okay. Double check. Yep. 1, 2, 3. 1, 2, 3. Looks good. Okay. All right. So that wasn't quite right. Let's do the opposite here. Let's do. I don't think that matters. I don't think it matters if we do this. Let's see. X, Y. Let's try that. Let's invert it. Nope. All right. If you have any ideas, let me guys know. Feel free to backseat. Why are my mouse pads low-key indestructible? I remember the day of mouse pads. Let's see if we can get our matmul correct. Let's see. I really want to get it right. All right. So we've got our A times B. How do we get to 30? Is there a dot product going on in there? Is that what's going on? This is matmul. It's not a dot product. So it's 1, 2, 3, 4. How do we get to 30? How do we get to 150? How does that happen? That's what I'm kind of curious about. Let's see. XXX. Do we have to do any addition? Because the final result seems fine. So let's see here. Steven, let's do a rubber duck overview. Can walk through the code and why. All right, let's do it. All right, let's do rubber duck. We'll do rubber duck. Okay. So we've got two matrices here, right? Which each they're matrices. So they're multi-dimensional arrays. They are the same dimension. And when you rotate them or you transpose them, they are also the same dimension. So we're doing for x and x to enumerate the indexes on the matrix. The same for A. And this gives us the ability to get every single member of the array. So our array looks like this. This is the array right here. 1 to 9. 1 to 9. So it's got 3 elements in it. Do you play chess, student 19? Yeah, I do. I play chess. I got a pretty good score. I used to play with a chess master every single day. And I played with 2 chess masters, 2 different ones, for every single day for like 3 or 4 years. I never won. I tried my best though. Hey, Jinlu, good to see you. Welcome on in. Happy to have you here. We are doing some Pytorch today. About you ever trying to implement it yourself? Yep, yep, exactly. We're trying to do A-B. I wonder if there's a rubber duck and had it was 4 years old. I don't know. What color scheme is this? Hey, how's it going there? This is color scheme groove box. That's what it got. Groove box there. Got the groove box color scheme. I think you once again on one of the chess masters. One time, but it was speed chess. I was like, okay, speed chess. Each move is like 2 seconds, or right, at least 2 seconds. It was speed chess, and I barely won. Kevin, you remembered that? That is amazing. That is so amazing. Jinlu, I'm trying to make my own grader now out of course, and it's not working, is it? Basic custom logon screen for Linux. Jinlu, that sounds pretty neat. I think that's pretty neat. All right, so why are our numbers not the same? That's what I want to find out. PubNub reminds me of Grubhub. Oh yeah, Grubhub. Well, you know what? There might be something to that. Can you ask a question? How to write custom training loop in Pytorch that allows to have hard HAW? What is that? To pass a single state between 8K token chunks without losing the gradient. I have no data set. Eyes for gaming. I kind of think I know what you're talking about, though. I would need to sit down with you to learn more. I would need to ask more questions. I don't know, make one of the training the best way to focus on making it efficient, effectively workable in a mid-end consumer-grade laptop. You got to keep your matrix small. You can't go too big because it's a consumer-grade laptop. Harmonic wave encoder. I mean, maybe. All right, let's see here. So what? Let's see. What are we doing? How do we get to 30? So that's my question. How do we get to 30? Here's what we should do is, let's make this smaller. Let's make it smaller. Let's do a 2x2. Here, let's do 2x2. Okay. That'll make it easier. I think that'll make it a little bit easier to do. All right, so 9, 12, 24, 32. Okay. So why is this? So 1, how do we get to 9 first off? How do we get to 9? So 4, do we have to add them? So there's some addition that I'm missing here. So see, so the first element is 9. So we do this times this plus How do we do that? I'm missing a spot. Okay, I forgot. It's got to be Okay, so I forgot. Okay, so here's how we have to do it. When we're doing the multiplication, let me type this in real quick. So 1, 2, and 3, and 4. So when we are doing this, let's do another one here. When we're when we're doing the multiplication, what we have to do is not only do we pivot, so we rotate, but we need to do this, let's see, 6 again, 6, and this, and this, and this, right? So we got to do this first one needs to do all of them. So we need to grab every single element, and that returns the value. So that would be 4, 5, 6, 7, 8, 9, right? Is that it? Or is that not quite right? All right, let's see if we can get that. Okay. So 1, 2, 3, 4. Let's try that again. Nice. Okay. So 7. Yeah. Okay. So I messed up the algorithm ever so slightly. What we need to do is we need to do more than this. We got to do more than this. Okay. So value equals val equals. So we've got a row. And then for every element. So this is going to be a double for loop. 6, 7. I know, right? We'll get it. Before we end stream, we'll definitely get it. I don't know how to make one. The training, the best focus. Yeah, okay, got it. Harmonic encoder. All right, just double checking on the chat there, you guys. So good to have you here. I think we can get it. I think we can get this. 1 second, let me reload that. Let's see here. So the chat disappeared on my screen. I got to bring it back. There it goes. Okay. Very good. Okay. Continue. All right. So I need to, the value that I want to return to append needs to multiply every value, every single value in the array by each other. So for example, A0, 0 needs to be multiplied by B0, 0, 0. Let me type this out. And then we need to add, we do 1, and then 1. Actually, we'll do 1 here. I think that's better. Let's do 0, 0. And then we'll do 1, 0, and then 1, 1. Okay. So we need to do this part right here. And then we need to add that together. That's what we're missing. That's what we're missing, you guys. That is the algorithm right there. That's the algorithm. That's what we got to do. And so if we do that, then we got the right matmul. Then we actually matmulted. Second loop needs to enumerate your X row and go over the columns, I believe. Yep, Crow, you got it. That's what we got to do. We got to enumerate all of it. So we need another for loop here. Let's see, we need every single element that we're multiplying by. So we're doing every element. So let me double check this. So we'll do, so that is 4, 5, 6, 7, 8, 9, 10. Although that doesn't quite look right. Right? Is that not right? Hold on a second, you guys. So this doesn't seem right either. We're missing something still. I might be going overkill. Let's see here. Let me comment these out real quick. Let's rerun this. Double check. Okay. Where's Val at? Okay, let's comment that out. Or paste it in Discord. All right. Thank you, Savan. Thank you. Thank you. Well, I'm over here struggling. Okay. So 7. How do we get to 7? I see. Oh, so this is 7 right here if you add that together. So is it per row? Do we need to do just the row? Is that what it is? Check it out, matmul illustration. All right. Let's see if we can. Let's see what we got in Discord here. General chat. All right. Scrolling. Nope. Maybe put it in memes. Where'd you put it? Did you put it direct message? Okay, we'll do direct message. I have to hide that. I have to hide it because I don't want to share. Okay. Oh, perfect. Okay, here. Let's bring this back. Okay. So we can implement this right here. We can implement this. Equals at 1, 2, 3, 4 times 1, 2, 3, 4. 19, yep. 1 times 5, yep. Plus 2 times 7. Let's see here. Okay, 2 times 7. Is that because we pivoted? We rotated? How does this work? Is equals 19. 19, 22, 43. Okay. 1 times 6 plus equals 22. 22. 1, 6, 2, 8. 22. All right, I'm looking at this. We're trying to figure it out. You don't have to write these kinds of algorithms very often. You don't. So 1 times 5, same position. 2 times 6. 3 times 7. 4 times 8. right? Do we have to do those? We have to do those as well, right? But then there's 50 here. If 4 times 8 is not 50. But you add them together. So is it 3 times 7 plus 4 times 8? 1 times 5 plus 2 times 6. Shouldn't it be 6? 1 times 6 plus 2 times 8. Is it because it's because we have to transpose it. Right? We transpose it. That's what's missing. Assuming you're building a sorting library. Hey user, how's it going? How do you improve logic building? Well, we're trying logic right now. That's what we're doing. We're making our way. Let's see here. Okay, so I just need to get, so 1 times 5, was there, how do we, since this is the corner, and then 6 is rotated, which direction? So I'm trying to figure this out. So 2 times 7, 2 is 7 here. Oh, I see. Okay. So on this dimension, and then this dimension. So these 2 dimensions right here. Okay. So we need to do these 2 first, and then you do these. So 3 times 4 and 6 times 8, or 4 times 8, right? And then 3 times 6. I'm trying to figure this out. Check in general chat. I pasted something better. Did you? All right, in general chat. All right, something even better. All right. Whoops. Didn't mean to do that. 1 second here. Let's just bring that down. Go over here. General chat. We're getting things going here. We're gonna have a matrix multiplication here. Oh, you've got an introduction. All right, so let's watch this real quick. 1 second. Okay, let me pull this up. All right, we're gonna consult the internet for a second. Here we go, you guys. Matrix multiplication. Let's listen to the teachers. Okay. All right, so this is 2 different matrices. Is it going to transpose one? Yep. So the first row with the first column, 9, 4, 0, 9, and you add them together, and then how do we do the second one? Oh, and then you first column, row. Okay. All right. And then you go to the last column, right? The last row here, and then you do the same thing again, and then you root through it that way as well. So you need to do column by row, column by row. Okay. Okay, got it. Column by row, column by row. So let's see here. Okay, this makes a lot of sense. We're doing matrix multiplication now, you guys. Matrix multiplication. This is often used as in inventories, you think? Is it? For inventories? Matrix, thank you for the hearts, you guys. So we can do this. We can figure out how to do that easily. We can make that happen. All right, so column by row, 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 column by row, row, row. Okay. Let's see if we can make that happen. Let's pause. Let's pause that. Okay. All right. So column by, so this would be A. So I was 1, 2, and then we do another one here. So it's 1, 3, 4, right? And so 1. So this and wait. No, go back. Hold on a second. Control V. I want this. Can it go like that? Will it be like that next year? I want to highlight it on the screen so I've got everything correct. Right. So like that. And then this. Okay. So we multiply these guys and add them together. 1 times 1 plus 2 times 3. And then we do 1 times 2 and 2 times 4. Okay. I'm a beginner. Hey, we're doing the dot product is the same. Nice. It's actually row by column, right? Yes, exactly. row for every column. So this is a column, and then we've got the row here. So row, we got columns. Okay. So let me copy and paste this right up. Actually, we don't need to do that. Let's close that real quick. So now we're in it. We're into it. So see, I wasn't far off when I was talking about this right here. So we were making it. We would have gotten there. We would have gotten there. I was really close. Okay. So let's say row and then column. Is that right? Row. So this will be X row. We need, okay, row, column. Okay. Let's hide this. Hide that for now. Hide this for now. Okay. Okay. So for column in A, or I guess we say B in this case. It doesn't matter because they're the same shape. It's of an in higher dimension as far. Yeah, it's multiple types, but yes, you are all right. Okay, good. Can we use NumPy for this? Yeah, you can, Goku. You can totally use NumPy. We're just trying to get this going here. We're just trying to get this going. Which software for beginners? Hey, how's it going there, Trophies? Trumphies, good to see you. And Kala, hi, welcome on in, you guys. All right, so we've got the row. All right, so let's say our val is going to equal. We need to go through this algorithm. So it'll be a. Let's see, row, and then column. Times b. Row. Not this. It's not this. Plus equals. Val plus equals. And then val equals 0. Okay, val is going to equal 0. And then we're going to append val at some point here. All right, so how do we do this? Okay, so we need to loop through. We need more loops is what we got to do. We got to do more loops. Greetings from Russia. How's it going? Hello, bro. Milan John, good to see you. Welcome on in. Happy to have you guys here. We're doing a matrix. We're writing our own matrix multiplication function, and it should be super easy. Your guys, oh, Python. You're like, oh, Steven, it's like the easiest thing in the world, and it should be. And we're not far off. We're not far off. We just got to make sure to get everything in the right spot. Is what we got to do. Everything in the right spot. Okay. All right. So for C. No. We're gonna get something in here. We need another for loop. All right. So plus equals, and then we're going to append. Although it needs to be. So that's the row. Append row. And then, yeah, so that's a multi-dimensional array. We're looking good there. Okay. Have you seen the CUDA thing? Maybe related to what you're doing? Yep. It sure is. Yo, Steven, add you on LinkedIn recently. Happy to meet you. Hey, Mangu, sounds good. Yeah, we'll have to connect. I'll connect here. So I'm actually I'm locking in now. I'm locking in. All right, so row times call. So this will get us the first one. So that's the first one. And then it would be, so row, all right, so 0, 0, and we need to go the top row, right? So let's zoom back over here. All right, and it always goes, okay, so let's see here, and it always loops, so 1 1, and then it goes 9 4, right? Or does it go? I'm double checking. Okay. I would have figured this out by myself. Yeah, we're figuring it out. Well, the good news is we've got the answer already. We've already got the answer. We just need to match the answer. So we can mess around with it. So let's see here. So it needs to be, so it's basically going to be this. And it needs to be extra though. We need to go a step further. I think we need to do more here. We need one more bit. I think we need one more for loop here. So then we will append the value. The row. No, we need to append row here. And we need to append the value. Maybe. Yeah, okay, there we go. There we go. Perfect, okay. Now we're good. I like this music. Kind of neat music here. What's this about? Hey, how's it going there? _E. We are building a matrix multiplication function because that's just what we got. We got ourselves stuck into this. We got ourselves stuck into it. And we need to figure out. All right, so this will be for step in range. Well, this. I think we can do that for step in range, or well, maybe. So we've got a row, our column, and then we need to. It sounds complicated. It's not though. It's not complicated. It's actually pretty easy. And we're just me with my best help. Gets me thinking back to the equation stacked on the top of the other. Yeah, that's basically where we're at. We'll get this. I promise. We'll get this. And we've got time. We've got time. We probably won't get to the memes though. We won't get to the memes because I do have to go and get ready for the upcoming podcast. You guys, we'll get ready for the podcast that happens at 11 o'clock. So I have to drop out before then to get ready. We're implementing matrix multiplication as best as Steven can. This is the actual step here. So row, column plus 1 plus step maybe. Is that what we want to do? Did I do it? Row, column plus step. That'll cause a problem though. Row, yep. Column. Let's see what this does. Let's see what it does. Let's see. No such file. All right. CD. Okay. Please. Thank you. Okay. Colon. Okay. Row, a row, range, step 8. Oh, okay. A row. What? Oh, what? Really? That should work. That should work. List indice must be of indices, not list. Oh, did I get it wrong? Hold on a second. Did I get it wrong? I might have got it wrong. One second. Print row, print X. I want to make sure. All right, so let's do that again. All right. Yeah, it's row. It's row. It actually is row. So it should be row. I'm pretty sure. But just in case, what I'm going to do is I'm going to comment that out. Okay. Yep, 0, 1, perfect. So let me hide that really quick. And I want to do print col. Okay. See what I see here? I know what we're talking about. I knew what we were doing. Okay. So 0, 0. Yep, 0, 0 is going to be the first one. And then we need to, right, 0, 0. And then, bop. Right? Let's see, let's go back to this. All right, so. Let's do the first one. Let's just get the first one going. All right. So 0, 0, right? It needs to be 0, 0. And then it iterates over to, it iterates down the rows. Okay. So this is it. This looks like it's it right here. This actually looks correct. So we're not far off. Obviously, we need to do len. I think that's better. B maybe. List indices must be integers or slices, not list. How about we just say col? Step range. Okay, so row, a plus row val, list indices. Okay, this is a problem here. You're supposed to say, Steven, look, you doubled up on the variable. Look at you, did it wrong. You did it wrong, Steven. You got a problem right here. It's obvious. That's what you should say. Hey, Lori, is that Lori? Did I say your name right, Lori? Thank you for becoming a channel member. Good to have you here. Welcome on in. Thank you for clicking that button. we're actually doing coding here. We're going to really get by the end of the stream, which is going to be here in a little bit. 40 minutes after the podcast, bro. Where can I find the podcast link? In Discord. Yeah, it's in Discord. I'll also paste it to you guys here. I'll paste it to you guys here. It looks like this. Copy paste here. This is going to happen in 40 minutes. In 40 minutes, you guys. In 40 minutes. And I do have to get going, so I'm going to try to lock in really quick. I'm going to try to lock in, but I will see you guys there. We are very close. We are very close. All right, so this is why. It's right here. All right, so new row equals. All right, we'll say new row like that. And then we'll go over here. New row. New row. Okay. That's why we had it wrong. We were right. We just had a little problem right there. We just had a little problem. So let's see. Oh, we're getting closer. We're getting closer. All right, so row, column, step, okay, plus equals for each. All right, so it shouldn't be, see here, we need 7, 10, 15, and 22. So we're not too far off. We're not too far off. All right, so column, and then there we go. Hi, bro, what are you building? Hey, how's it going there, Big Money Talks? Welcome on in, good to see it. We're trying to build a matrix multiplication, right? So we're basically trying to mimic this. We're trying to mimic this. We're not far off, though. We're really close. So I don't need that anymore. All right, let's print that out. Okay, so how do we do this? So the 0, row, column, it should be 1 times 1 and 1 times 3 plus 2 times 1 and 2 times 3. Right? So let's math that out. 1 times 1 plus 1 times 3 plus, right? Is we're doing it right? Is that it? Thank you for the hearts and reactions, you guys. I do have to get going here pretty soon, so we might not finish this. We might not finish it. It's just like super simple. 2 times 1 plus 2 times 3. Is that right? Did we get that? Okay, so that'll be 1 plus 3 plus 2 plus 6. Is that right? So let's see what the actual answer is. 7 though. So this math right here doesn't even work. That math doesn't even work. So we're not too far off. It's just that we didn't get it. Are these going to be different numbers here? Are these totally different numbers? They are different numbers. Okay. So this is 3, 4. So I count 4. I don't count 7 there. Foul play. How's it going? Thank you for subscribing. We're figuring this out. All the lag is back. Thank you to Steven. Oh, thank you, Savant. Transpose it would be useful here. Exactly. Oh, we got to transpose it, right? That's right. We could do a transpose. Right. Which is basically, let's try that. Let's do that. Col row. All right. Let's see if we can get that closer. It's still got zeros for no good reason. There should never be a 0. There should be no zeros. Why is there even a 0? Why? Why is there a 0? That doesn't make any sense. It makes no sense. There should never be a 0. All right, so print. Let's print this out. Let's debug it here. Okay, let's print it out. 3, 1, 4, 3. See, there's no need for a 0. There is not. That's not no need. In Python, thank you guys for the actions, you guys. Align them based on how you have them in the array. Yes. Pretty close. So what if we did col instead? I'm gonna start messing around with the numbers. We're a little bit closer, although why is there a 0? That doesn't make any sense that there should never be a 0. Value. I mean, obviously val is here. Do we need to? So we're appending the val here on the outside, but the val is 0 here. Do we get it wrong? Do we need to do val here? Okay, let's try that. Thank you for the hearts and reactions, you guys. Appreciate it. Let's see. Val. What's going on here? Because what? Look, if we did this, and we printed that out, that would be 6 and 7. I see a 7 here. Well, you guys, I feel silly here. This is a real-time closed caption. Yep, working on the stream. You got it. This is real. We're live right now. All right. We're just so close. We're like so close, you guys. So very close. Call row step 0 B 0 colon. I mean, it's the same either way. I just don't see why I'm getting a 0. Also, let's undo that real quick. Did I have a 7 in there? I have 9 and 12. Hey, Damon, good to see you. Welcome on in. All right, we don't have much time left. We've got 5 minutes. We got 5 minutes. How much can we make it? All right, so we got a new matrix, new row, then the new row. We get the new row here, the value. All right, so this gets us the value. I want to. This should be printing a lot more. It should be printing a lot more. I don't see why it's we don't see so many prints here. Right? So let's take a look again. So see, this is very weird. This is very weird. It's only doing 2. This is very weird. It's only doing 2. And it should be 4 at the minimum. At the minimum, it should be 4. Because it's a nested for loop. This is so weird. You've never crossed your mind is using a library for captions. I was thinking he speaks in captions. Yep. How's it going there? Hey, how's it going, VLRS? Welcome on in. What is missing here? This is very odd. So we got a 4. So let's see. Watch. If we print the row, and then we print the column, we're going to see a lot of prints. And then we print the step. We're going to see a lot output. Yeah. See, this is correct. This is correct. This is what we're looking for, right? That's a lot of stuff there. Let's see. All right, let's not print this here. Okay. Yeah, that's plenty. That's the exact number that we're looking for. So value, maybe. Let's do instead. Let's do this instead. All right, let's try that. That's going to be 9 and 12. All right. Hey, Nick Rogers, thank you for subscribing. Welcome on in. We got 4 minutes. We got 4 minutes, you guys. And then we will see if this works or not. Let's see. So we are missing. It's just we're missing something. Something I'm missing is obvious, and I'm not seeing it. Row, column, print column, val, step, and range. So then we can loop through it. I can get Steven's GitHub and do explore cool projects, please. Sure. It's on Discord, you guys. It's on Discord. It will be in the links, under the links section, under links channel. Hey, peace, hello, what are we building today? A matrix multiplication, which I've built many times before, but for some reason I've got some little bug in here that I can't figure out. Some little bug. Hey, how's it going there? Lysandra, thank you for subscribing. You're missing Hello World. That's what it is, we're missing Hello World. Matrix multiplication, which should be easy. And I've got it right here. This is all we need. It's just, there's like something missing on the screen. We're missing something, you guys. Something simple. Something very simple. Print. All right, so this is this. All right, let's try that. 3, 3, 4, 3. There's the 7. There's the 7. I found it. It's just not doing as much. It's only going through. It's only happening twice. It's just so weird. It's so weird. I need to figure out this. There's actually some very simple problem that I can't see on the screen now. Clearly testing out of patience. Yep, you got it. Exactly. We're testing your patience. Don't worry. We'll wrap this up here. Steven, hi. Do you have any videos on how to do serial data to a CSV through file? On a microbit? Through microbit? I don't even know what that is. I don't even know what that is. What is microbit? There's plenty on here for this to work. Let's see your step. Why? Here, I'm going to. We're gonna make some changes here. We're gonna make some changes. Okay. That's what's wrong. Okay. All right. So we need to do len b col. That's what's wrong. Hey, we're getting closer there. So the length of the B, got it. Okay. Perfect. Okay. Doesn't matter so much there. Okay. So we've got a little bit too big. Okay. We're wrapping up here, guys. I got to get going. It was a lot of fun hanging out with you guys today. We'll see how far we get here. It'd be so cool if we just fixed it right here at the end. That's 7. I see it's right there. We're like a step away. We are a step away. Let's go row. Okay. Yeah, that won't work. Val plus equals on the column, row, column. That should work. All right. Well, I'm messing around with that. I'm trying to get it to work. Bro, Indian time, 12 a.m. Event show starts at 12. That's really late. You said 5 minutes remain. Yep. 5 minutes remain because I got to go and get prepared. And I'll be on there. Hey, little bird. Good to see you. Welcome on in. Unexpected indentation. All right. We can fix that. Okay. All right. Here. 1 second. Right here's the problem. Okay. And it's still not working. I just figured it out. Oh, right. Okay, perfect. Okay. Step closer. We're a step closer. And not quite. Not quite. Okay, bro, thanks. I'll meet you there. Sounds good. Sounds good to me. We almost did it. We almost got it. It's not that far off. All right, here. Cool. And that won't work either. I know that won't work. All right, we missed something. We got something wrong. We'll figure it out. We'll figure it out. Let's see here. Here, 1 second. All right. I want to fix this. All right. Before we go, we're gonna fix this. All right. See here. Fix matmul. Okay. All right. We're gonna fix this before we go. You heard my alarm clock go off. So that was it. So we're gonna fix this before we go here. Okay. Okay. Without. Okay. Perfect here. Okay. So rows. Okay. So we're gonna use some help. So see, x equals len a. Y equals len a0. Z equals len b0. So there. Now we've got our multi-array here. Okay, so now we've got a new matrix. We got a new matrix right here. Okay. Okay. So now we're going to go for I, or basically for rows. Okay, rows. Okay, for I in range. We're gonna try. We're gonna try really hard. We're gonna try really hard, you guys. We'll go J and is it Y and K in Z. Okay. And then we're going to have our new matrix going to be here. Okay. Thank you for subscribing, Gajar. We're trying really hard here real quick. All right, so that is IK. All right, so new val is going to be A, B, IK, I, and K, and this will be K and J. So that's the new value. And then I believe let's get rid of this here. We can append, let's see, get rid of this. Okay. All right. Append value, append the row, return it. Did we do it? Not quite. All right. We need to define val, right? So val, I think we just say val equals. I think we just do, well, no. Val equals 0. Let's get that right. Almost. New row. Where's new row at? Oh, we need to define new row. New row equals array. Okay. Oh, so close, you guys. So close. Oh, so close. Oh, we were just a few smidgens off. All right. Let me do this real quick. Oh, I'm so late. We're gonna be so late, you guys. We're gonna be so late. So I'm gonna copy and paste a few smidge here. So this is Y and X, I believe. B, that will be Z. So Z is here. And then instead of doing this new row stuff, we're gonna say new matrix is gonna equal basically what we just did. Okay. For this part here. Okay. All right. We're gonna make it. We're gonna make it. I'm determined. I'm determined. We're gonna make it. We don't need to append row. All right. Did we do it? Did we do it? Hey, we did it! Check it out! All right, just a friend on that. Finally, thank goodness. All right, I had to sneak into a little bit. All right, I had to lock in there, you guys. I didn't pay attention. We got to get going there. Thank you so much for hanging out and spend time with me today. Thank you for subscribing. We'll be live here at 11 in about 20 minutes. About 20 minutes. I'll send the link for you guys. We'll be here in about 20 minutes. We'll be live. Thank you so much for joining me today. It was a lot of fun. I got to get going. I got to go get prepared. See you guys in about 20 minutes at that link. I'll also post it in our Discord channel, you guys, over here. Hey, there we go. All right. You also had it here. Here's the actual answer. I was typing it all myself. But we did it. We actually matched it. It's actually matched now. All right there. We did it. All right. Thank goodness. Thank goodness, you guys. It's good to see you guys. All right, I'm headed out. See you guys. We'll be back. We'll be back on Monday. But also, and if you want to join, we are talking about large language models here in 20 minutes. All right, you guys. Bye for now. See ya.